This block, all we're doing is you're just updating. You're just updating value. You're just updating the, what? Hello everyone, today we're going to be optimizing the Nesterov momentum update within our neural network library. The reason why we're going to do that is because Nesterov's momentum update is probably the quickest update method that we've implemented so far, but it's also the most taxing because what you have to do is you have to simulate a future instance of the recurrent neural network. So create a new neural network, do a forward pass for it, and then do a backprop for it, get those deltas, and then use those to update the weight. We're just going to implement a lot of the same optimization tactics that we used yesterday, using local variables, changing the V from a dictionary to a table, stuff that we've done yesterday. So one thing I do want to quickly do before we actually do this is I want to go through and I want to see how long it does take Nesterov's momentum. Just so we have, like an initial benchmark, and then we can go from there. So it's about like 0.01, which is crazy. So we need to get this down to 0.00. So let's get to it. So similarly to what we did with backprop yesterday, let's go through and let's start to figure out, which blocks of code within our Nesterov momentum update are eating up a lot of our time, or a lot of our processor time. That's very interesting. Not what I expected. So block 1 is pretty much instantaneous. Block 2 is also pretty much instantaneous. Block 3 is also pretty much instantaneous. I thought all this was going to take up at least a little bit of time. For some reason, this backprop is taking quite some time. But the most interesting thing to me is just updating the weight here also takes quite some time. I guess we have to take a look at block 3, 4, 5, and 6. Go through block 3 first, because I think block 3 is the easiest. I'm experimenting with something right now. We'll see if it works. Basically what I'm trying to experiment with is, could I basically create a property for a Nesterov momentum update that the algorithm is able to tell, number 1, and then number 2, if I can do that and it's able to tell, hey, this is Nesterov momentum update, because right now one of my biggest problems is it goes through backprop twice. It's not really reflected here, but it is reflected in the total time it takes to go through an SGD, which I don't think I printed out. And again, that's because SGD already calls backprop calls Nesterov then calls a forward pass and another backprop again. It really does not need to. How do we check if a function is equal to something? Oh, this is very cool. This is very, very interesting. This might actually be what I'm looking for. Let me see if I can do this. Oh, I really hope this works. I think I found something that works. Before I go through and before I start fixing up the rest of the block, we've already done a couple of them. And not only do I need to optimize Nesterov's momentum update internally, but I also need to update it externally. Optimize it externally. Nesterov's momentum update gets called every time you want to update the weights. The problem is Nesterov's momentum, because it needs to look ahead, it'll create a new neural network, a new recurrent network instance, do a forward pass on that, and then do a backprop on that. But Nesterov's get called within the original backprop, and so now there's backprop twice. The first backprop it doesn't need, and so that's just a waste. That's a waste of time. That's something that can be optimized. Second backprop is important, so why don't we just get rid of the first backprop, and then that will shave some time off how long it takes for us to do an update pass with Nesterov, and then we'll come back and then we'll optimize internally as well. So hopefully what that will do is essentially, when backprop is called, but we are using Nesterov momentum update, it'll just calculate the loss, which is all we need, and then bounce out of that backprop. Okay, looks like it's still working. Our loss, we have a loss. It's going down. Oh, thank God. Okay, we didn't break anything. Boom. Let's move on. So now with that being done, let's actually go back to what the purpose of today's episode was. So block 3 over here needs to be optimized. I don't know how the hell we're gonna optimize this. What's taking so long here? All you're just doing is you're just creating the variable. What? So yesterday, one thing I learned is try to use local variables as much as possible. So that's all I'm gonna do today. Let's try now. And so what we were getting, 0.002. There shouldn't be any time registered for this section where all you're doing is you're just setting parameters. Really don't understand why. So what's the average? And then we'll just see whether or not what we've done has actually changed anything. I think the average is around like 0.001, and I'm just trying to get this down to 0. Okay, so let's see whether or not we've actually changed it in any way. No, you're not. Why does it take so long just to set parameters? Let's move on to the next blocks, and then we'll come back to this block tomorrow. This doesn't make any sense to me. And I mean, there's not really much else we can do. It calls forward pass, takes as long as forward pass takes. What's crazy to me is that a whole forward pass where, you know, it does a lot of like matrix multiplication, blah, 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 blah. How the hell is that faster than setting these hyperparameters up here? This makes no sense. How is it that a whole bunch of matrix math is faster than just setting, you know, this is equal to 2, that's equal to 5? My mind's blown. And so then for backprop, one of the things I want to do is I want to change this look ahead deltas into just a straight up array. Hopefully when it is an array, we can loop through it faster. Let me just run this as is and see what everything's at now. It's still not the greatest, to be very honest, and I'm still quite disappointed. But from the numbers, it looks like this section here is on average, no, it's still quite high. What the hell? These two, there's not really too much we can do, because in these two blocks, in this block we're calling forward pass, this block we're calling backprop, so there's not really much we can do there. For some reason, this block and this block, they take so long. This block, all we're doing is you're just updating value. You're just updating the, what? Why does this take so long? That doesn't make any sense to me. In an attempt to try to use a local variable rather than a global variable, which I guess these self variables are global. And especially because like we do reference this self v a lot. And in this block of code, it's the only thing I can really think of that might be slowing things down. Every time I make mention of self.v, I would just change that to just regular. So we are using the local variable instead. Now that I've actually changed and using a local v variable rather than a global v variable, does that change anything at all? It doesn't really look like it, no. It still blows my mind that matrix math is faster than setting variables. It makes no sense to me. Let me just make sure it still trains and error still decreases and it still learns the words that we fed it. So it looks like it, but again, FPS is still stuck at 1. So did we even change anything today, I guess is my question. Maybe not. Let's get rid of all those and then we'll just run it. I think last night when I was taking a look at it, it was like hovering around 1.7, 1.5. And now it's like 2.7, 2.5. So all of that for an additional frame I don't think is really worth it. Oh, my head. I'm so disappointed. Multi-threading to see if it gets through that chunk of calculations quicker. Yeah, multi-threading is something I'm going to have to start taking a look at tomorrow. Clearly, from all that I've done in the past 2 days, I've only added like 2 frames. That's so sad. That's so sad. Okay. So essentially what we've done is we've gone through Nestrov's momentum update and we have optimized everywhere we possibly could. Where we could, we're using either local variables or we've just saved the functions and just local variable as well for reference. Another performance issue was stochastic for every training instance, for every sequence, we'll call forward pass, they'll then call backprop. Backprop will then call Nestrov's momentum update. Nestrov's momentum update will then create the look ahead. It will then call another forward pass sequence, and then it'll call another backprop sequence. And so we just implemented a check or just a way for the algorithm to know whether or not we are using Nestrov's momentum, so it can kind of skip that and won't actually go through. And then when we're down in backprop, all we're doing is we're taking a look at whether or not we are using Nestrov's momentum. If we are, all we just need is to just calculate the loss. Now, what were the results? I believe the frame rate before was 1.5 to 1.7. Kind of doubled the performance of it, but this is quite slow. My stupid mic cable was caught in my foot. I mean, what I could do is I could set this at the very, you know what, that's for tomorrow. That's a good idea. Let me write that down. Why do I always have like good ideas right when I want to hop off? Where were all these good ideas like an hour ago? Why am I setting true? What does this arg do? I don't think I need that though, but okay, whatever. I implemented it some while ago. I'm not gonna touch that because I don't want anything to break. It works as is. We're gonna leave it alone. We're gonna move on.